Imagine that you rolled two dice. The question is, what is the probability that they will show up non-identical numbers? For example, 2 in one and 5 in the other, or 6 in one and 4 in the other, and so on. To solve the problem, let us first look at the sample space omega. The sample space omega is a set of elements which are 1, 1, 1, 2, 1, 3 and so on through 2, 1, 2, 2 and so on up until 6, 5 and 6, 6. It is easy to visualize the 36 elements in the sample space omega using a checkerboard. The vertical and horizontal axis correspond to the two dice under consideration. For each of the 6 possible outcomes in one, there are 6 possible outcomes in the other. Remember the multiplication rule of counting? The event in the problem statement is getting non-identical numbers in the two dice. Let this event be A. Now, what are the elements in the set A? They are the ones indicated by the red dots. Counting them gives the number of elements in the set A, that is 30. So, the probability of getting non-identical numbers is equal to P of A, which is mod A divided by mod omega, which is 30 divided by 36, or 5 over 6, which can be represented as 83.33%. What about the following question? What is the probability that both the dice will show identical numbers? Here again, we can consider an event B, which is defined as getting identical numbers. What are the elements in set B? There are 6 possibilities. These are contained in the diagonal of our checkerboard. That is 1, 1, 2, 2, and so on until 6, 6. There are 6 elements or outcomes in the set B. The probability of getting two identical numbers will be P of B, which is equal to mod B divided by mod omega. That is equal to 6 divided by 36, which is 1 over 6. And that can be represented as 16.67%. Notice that the probability of event A and B are adding up to 1. Something very interesting is happening here. Look, there are no common elements in the sets A and B. And the elements in sets A and B together make up the sample space omega exactly. Nothing more, nothing less. Here, omega is actually the universal set. Hence, the set A is a complement of set B and vice versa. In this situation, we can say that probability of A is equal to 1 minus probability of B, which can also be written as 1 minus probability of A complement. This is a very useful relationship and can be effectively used in solving probability questions. Finally, how do we apply this relationship in this situation? So here it is. To find the probability that the two numbers will be non-identical, we could subtract from 1 the probability that the two numbers will be identical. So the take-home message is that probability of A is equal to 1 minus probability of A complement.